specific resistance. It is represented by rho. It is also called the resistivity. Resistivity. We know R is proportional to length, that is a resistance. R is resistance of the conductor. Let me consider a conductor like this, another conductor like this. So the area of cross section is smaller, in this case greater. So radius and the length is also different. So longer the distance, that is longer the length, greater will be the resistance. It is directly proportional. And it is inversely proportional to area of cross section of the conductor. So we can combine this, so L by A. So R is equal to, we can introduce the proportionality constant, rho into L by A. So this rho is equal to R into A divided by L. So this is the resistivity. Now, what is the unit of resistivity? Unit of rho is, that is you have got ohm, and this is meter squared, and this is meter, therefore ohm meter. Okay. Now let us consider a problem. The resistance of a wire, the resistance of a wire is 2 ohms, 20 ohms, sorry, 20 ohms. Now, what will be the new resistance? Resistance, if it is stretched uniformly, eight times its original length. Now, R1, let us consider, this is the original resistance R1, 20 ohm. What will be the new resistance? That is R2. When the original length, let me consider the original length is L1, and it is stretched to 8 times, means L2 is 8 times of L1. Am I right? Okay. Now, what about the area of cross section A1? And we do not know about the area of cross section when it is extended, so this can be A2. Okay. We know R1, let us consider this equation, is equal to R1 is equal to 20 ohms here. So let us make use of this equation. R1 is equal to rho into L1 divided by A1. What is R2? That is rho into, because rho is not going to be changed, we use the same material. So L2 by A2. So let us find out the ratio between these two. So R2 by R1 is equal to rho can be cancelled. So we have L2 by A2 divided by L1 by A1. We can reciprocate. So A1 by how much? L1. Okay. Right. Now the its volume remains unchanged. You have to note down this point. Okay. Now, what is volume area into length? Is it not? Area of cross section into length factor. That is volume. We use the same material. Volume is not changed. So in that case, let me have V1 is equal to A1 L1. V2 is equal to A2 L2. In that case, A1 L1 is equal to A2 L2. Am I right? Therefore, A1 by A2 is equal to what? L2 by L1. Correct? And instead of writing A1 by A2, I can put what is L2 here? We already know this is 8 L1. Am I right? So divided by L1. So that is equal to 8. So the ratio between the A is 8. Is it not? Okay. So we can suitably substitute here. Similarly, R2 by R1. R2 by R1 is equal to L2 by L1. L2 by L1 into A1 by A2. We can rearrange this by A2. So what is L2? This is also 8 L1 divided by L1 into what is A1 by A2? Just now we found it is 8. You can put 8. So this can be cancelled. So R2 divided by R1 is equal to 64. We know already R1. What is the value of R1? 20. Therefore R2 is equal to R1 into 64. So this is 20 ohm into 64. How much? 1280 ohms. This is R2. Just imagine when you extend the length by almost 8 times, the 20 ohms becomes 1280 ohms. So you are experiencing such a great resistance. Are you able to follow this?